video, I will explain about center of mass. So center of mass is nothing but a point where the entire mass is assumed to be a concentrated. For example, whenever you are having system of particles is nothing but number of masses connected together. So I am initially taking a case where two masses are connected by a rigid rod. So you know what is a rigid body means. Rigid body is nothing but, see, let's say you are having a body. If this body is said to be rigid, then the distance in between these two, any two particles if you are taking, then the distance in between these two particles will not change. For example, point 1 and point 2, distance in between them will not change. And in between these two, this will also not be changing. The point 3 and point 4. Whatever the motion, you can take it anywhere. This can have any motion. It can have zigzag motion, that can have a motion in a straight line. Still, the distance in between the particle will be constant. So this is a rigid body. Why? Because the distance in between these two will be constant, or in the distance in between any 2 points in the rigid connector that connects two masses will be constant. Okay. Now see, a non-rigid body is nothing but in the case of a balloon, it is made up of number of particles, but the moment you squeeze it, this come to a new position, something like this. Now the distance in between these two, if it was initially some value r, then that has been changed to a new value r. So this is not a rigid body. This is a balloon which is not a rigid body. I will come back to this. So to find the center of mass of two masses which are connected by a connector, this is also rigid. So how to find it? You have a reference point. This is point O. From this reference point we are going to take the measurement to different masses. Now this mass is connected. This mass is R1 distance away from the point O, and this mass is R2 distance away from the point, from the second object. So I can say the distance in between mass 1 and the point of reference is R1, and distance in between mass 2 and the point of reference O is R2. If this is the scenario, then center of mass will be a new position vector. This is basically a vector because this is having a direction and a length. So this is directed towards 1, this is directed towards 2. So you can have the same length in this direction also. This is same, and the length of this and this is same, but I can't say this as R2 because R2 is having a direction which is directed towards the mass 2. So I can say these two are position vectors. Okay, now the center of mass, that is the position vector of the center of mass will be equal to m1 r1 plus m2 r2 divided by m1 plus m2. So you will be getting the center of mass somewhere here in such a way that center of mass will be equal to, the value of the center of mass will be equal to magnitude of mass 1 into magnitude of r1 plus magnitude of mass 2 into magnitude of r2 divided by sum of the masses. This is center of mass. Now I can say, see, from here you can come across many important equations. See, m1 plus m2 is nothing but the total mass. So I can replace this as m1 r1 plus m2 r2 divided by capital M. Capital M is nothing but total mass, m1 plus m2. Just multiply the capital M to this side. M into RCM is equal to m1 r1 plus m2 r2. Now see this, we already have learned an equation in the second chapter, that is d by dt of differential of position vector, that is r or s. D by dt of position vector or d by dt of displacement is equal to velocity. Now d by dt of velocity is nothing but acceleration. We will differentiate the entire equation. We will be getting d, mass is a constant, so I can take mass and just differentiating. So d by dt of equation this, that is nothing but mRCM plus is equal to m1r1 plus m2 r2. M is a constant that will come outside. D by dt of center of mass is nothing but the velocity of center of mass. Let's say if this is center of mass, then velocity of this point. So velocity of center of mass is equal to m1 r1, that is nothing but velocity of mass 1 v1 plus m2 into d by dt of r2, that is nothing but velocity of mass 2 v2. So mass into velocity of center of mass is equal to mass individual mass into velocity of the particular mass, or sum of product of masses and velocity of the individual masses. See, this is nothing but what is mv, mass into velocity, that is nothing but momentum. So I can rewrite it as m into vcm is nothing but momentum of center of mass is equal to momentum of m1 into v1 is nothing but momentum of first body, m2 into v2 is nothing but momentum of second body. And we also know the equation that d by dt of momentum is equal to force. So again I am differentiating it, or you can differentiate this d by dt of this equation. Capital M into what is dv by dt, acceleration of center of mass, m1 into what is dv1 by dt, that is nothing but acceleration of the first body, m2 into dv by dt, dv2 by dt is nothing but acceleration of second body. I can get the same equation by differentiating this from dp by dt. dp by dt of center of mass is nothing but force on the center of mass is equal to force on first body plus force on second body. This is really important because you know that, see, if the net force acting on the body is 0, then that object have two options, either to be at rest or it can move at constant velocity. So from here, let's say if the net force acting on the body is 0, which is nothing but this is equal to 0, d by dt of this equation. See, differential of m into v, or momentum of center of mass, is nothing but force on the center of mass. Let's say that is nothing but the net force acting at the body. So let's say if the net force acting on the body is 0, in that case, that is FCM is equal to 0, which means you can't differentiate this. You can't differentiate this equation because differential of this equation is nothing but the net force acting on the center of mass. Okay, so if you are differentiating this, you will be getting 0, which means this is a constant, because you know that differential of a constant is equal to 0, which means this is equal to constant, or m into vcm is equal to m1 v1 plus m2 v2 is equal to a constant. What does this mean? That momentum will be always conserved, because this is momentum of first body, this is momentum of second body, which will always be, the sum of the momentum will always be conserved.